Okay, so we're going to do just some video examples here. And this particular set of examples are going to be coming from page 119, number 15 there. Okay, so we're going to do these examples together, and then you will be kind of on your own for the other set of problems, which happens to be page 121. Question number 5 there. So these are all some very good examples, but what we're going to do here is we're going to be focusing on page 119, 15, or question number 15 there. So let's start out by doing 15, or question number 15 there, A. So whenever I'm copying these out, really I should be paying attention to really where the carbons are. Okay, so a lot of times you'll find, just kind of as a shorthand, I like to just write in the carbons, but I won't do that this time, just so that you can see kind of what is actually in the textbook there. So the first thing that I'm going to want to do is I'm going to want to identify my parent chain. So in this case, my parent chain could continue to go on straight here, or it could curve up this way. And we're only going to do it this way just to kind of challenge ourselves here to make sure that we're not always just relying on the straight chain in the middle. So if I was to name this, first I'm going to go ahead and number my carbons. So 1, 2, 3, 4, 4 carbons. I've got bute there. So this particular parent chain is butane. Ane, because it's all single bonds. Okay, now I've got a branch. Sorry, I guess I should put that this is number 15A. So here I've got one branch that is got 1 carbon on it. So that's, oh, sorry here. That's a methyl branch. So methyl branch. So here we go. This is my methyl. Note I don't put monomethyl to indicate one. It's kind of implied. All right. So methyl, and that happens to be on the second carbon. So this is 2-methyl. Note that I numbered this in the correct direction originally. So it wasn't like 1, 2, 3, 4. 3 wouldn't have made sense there. We always want to make sure that the branch is on the lowest carbon. All right, so let's do 15C next. So 15C, just going to extend the page here. 15C looks like 3CH. Like this. Oh, there we go. And okay, so I'm going to try to find the longest parent chain here, and that longest parent chain will kind of do the simplest one here. Now note, when I go to number this parent chain, I want to make sure that the branch is on the lowest number, so I'm going to number this way. 3, 4. Okay, so 4 carbons in my parent chain. That means, again, we've got butane on our hands. Now, my branch has got 2 carbons. Okay, so that's S, O, because it is a branch. Okay, and then I need to tell it that this is on the second carbon, so this is 2-ethyl butane. All right, so now our next problem that we wanted to show here as an example is E. So let's look at E there. E is a pretty good kind of indication that we've seen before. So let's do D actually, because I feel like that's a really good example that we do together. So on D here, I've got Okay, so I've got a situation that looks like this. On D, so when I go to do my parent chain, this becomes my parent chain, longest continuous chain of carbons. So then what I'm going to be doing is I'm going to be numbering this so that this carbon here that has my branches attached to it, that is going to be in the lowest number when I go ahead and number this off. So I can number it 1, 2, 3, 4, 5, 6, but that would put this at a pretty high number at 4. So I'm going to number 1, 2, 3, 4, 5, 6. So I've got 6 carbons. So because of that, I have the parent chain hexane. Now I've got 2 different branches here, 1 and 2. They both happen to have only 1 carbon in them, so they're both methyl branches. I've got 2 of them, so I put in here dimethyl, and they both happen to be on the 3. Now, I've seen some students just put 1 3 here. That's not a good idea. Obviously, that's not the appropriate way that we do this, but also because it doesn't tell you that necessarily both of them are on there. And when we get into other situations where we maybe have trimethyl or that sort of thing, when kids go and put only 2 numbers in there, it kind of gets confusing. So you want to make sure that you always put a number for each branch that you have in your or attached to your parent chain. So make sure that that is nice and clear. Okay, as a final example here, let's do, I'm thinking we should do J. All right, let's do J on that page altogether here. So as a final example here, I've got a situation that looks like this. Now, in this particular example, I need to be really careful when making my parent chain that I make sure that I include kind of all of the branches that are going on there. So this parent chain isn't something that goes kind of straight across. The reason for that is because I've kind of got this cluster here at the bottom. So I need to make sure that my parent chain goes something like that. So now I'm going to number this to make sure that my branches are on the lowest possible carbons. So 1, 2, 3, 4, 5. 5 is going to be like that. So this is a 5 long parent chain. It all has single bonds. So my parent chain is pentane. Just like that. Now I've got 1, 2, 3 branches, and they're all 1 carbon, so they're all methyl branches. So methyl, 3 of them, so this becomes trimethyl, and so I need to represent 3 spots for all 3 branches, so this becomes 223 trimethyl pentane. All right, so now we've done some problems together, and you should do kind of the rest of those practice questions on your own. Now, what we're going to do here is we are going to go to page 121, and we're going to look at number 5, and we're going to do 1 or 2 of those together, just so you can kind of go ahead and work together how we would go from a name to compound. Okay, so what we're going to do here is we are going to do 5A together to start off with. So 5A is straight 3-ethyl hexane. So hexane is my parent. Okay, so hex right here. Where's X? Right here, 6. So a 6 carbon, ane, meaning single bonds. Okay, so that is the parent chain that I have for this particular structure. Then I have this branch, okay, S meaning 2 carbons. Where is that branch, you ask? Well, it's on the 3rd carbon. So I'm going to start out by drawing my parent chain. 1, 2, 3, 4, 5, 6 carbons. All right, and then I'm going to go ahead and I can number these. So 1, 2, 3, 4, 5, 6, and then I'm going to go and put in my branch. My branch is on the 3rd carbon, and my branch has 2 carbons on it. So now if I was to go ahead and draw this out as a condensed formula, this particular carbon would need 3, and then 2, 1, and I could kind of fill in ticks here for each of my hydrogens. So this would become CH3, 2, with the 1 hydrogen there. I've got another CH2, and finally CH3 here. And then for my branch, I've got my CH2 and CH3. Sometimes it's nice in order to just kind of put in the carbons there and little ticks for the H's so you make sure that you get them right. But this here would be the correct formula for that compound. Or sorry, the correct structure for the name of that compound. Let's do something just um, a little bit more complex, and we will do E together. So this is 3, 4 dimethyl 4-propyl heptane. Okay, so same sort of situation goes on here. I'm going to look at the last bit of this, and this is my parent chain. Okay, hept meaning 7 carbons, ane meaning all single bonds. I've got a propyl branch here, so this is meaning a branch. Okay, prop means 3 carbons. Where is that branch? It's on the 4th carbon. Here again, ul meaning branch. Meth, okay, meaning 1 carbon. Di meaning that I have 2 of them. And where are those 2? Well, they're on carbons, or sorry, the 3rd and 4th carbons here. Carbon 3 and 4, okay? Oh, geez. Okay, so 3rd and 4th carbon. All right, so I'm going to start out by drawing my parent chain of 7 carbons single bonded. 2, 3, 4, 5, 6, 7, they're all there. Okay, so I could number these off just to help me out. Now I'm going to go ahead and I'm going to put in my branches. So I've got 2 methyl branches, one on carbon 3, one on carbon 4, and then also on carbon 4 I have a 3 carbon. So just to help me out here, I'm going to put little ticks that represent the H's that fill in the bonds for each of these particular carbons. Beautiful. So now when I go to do my condensed formula, which is kind of the final step here, hold on 1 second, let me clean that up. Okay, so I have a CH3 joined to a CH2 joined to a CH, which is joined to a CH3 up at the top. Then I have a straight up carbon here, which is joined to a CH3, a CH2, CH3, joined to a CH2, CH2, and then capping off the end with a CH3. There we go. So those are a few of the examples from the assignment. You should make sure to kind of fill in the rest of those in order to help you out there with identifying organic compounds.